Hey guys, so this next lesson is more bearings, but we call it the second method because it's just another way that the bearing angle is described. So you can follow along with these notes there on Classroom. As always, we always start with our bearing line. And this method always uses an acute angle. So an angle that's less than 90 to show the direction. This is different from the first one that we did, because that one you could have something like a 300-degree angle. It was any angle, always in the same direction, always clockwise. This one is a little bit different because all the angles are always acute, and now you're either coming, you're always coming from north or south, and it's either going to be west of north or south, which would be this direction, right? So let's do our other line. Here's west. West of north or south would be to the left of north or south, or it could be east of north or south, which is to the right. East would be to the right, and west would be to the left. Okay, so here are a few examples on this picture just to give you an idea of what we're talking about. The first one is done for us. It says the bearing of A. So A is right here. It's 60 degrees. The line is 60 degrees to the left of north. So that's, we would say 60 degrees west of north. And so how you would say that out loud is you would say 60 degrees west of north. And this is how you would notate it, N60W. So bearing B is 29 degrees to the right of north. So that would be 29 degrees east of north. So you would write that north, 29 degrees east. Bearing C down here is coming from the south direction, and it's 58 degrees to the left, which is west. So it's going to be south 58 degrees west, or 58 degrees west of south. Bearing D, this last one here, is to the right of south, which is east. So we would say south 33 degrees east, or you could say east 33 degrees east of south. Okay, so that's the basics of that first method. Now I have a few examples that we are going to do. Okay, so example 1, we're given a bearing from A to C is south 52 degrees east, or is 52 degrees east of south. The bearing from A to B is 84 degrees east of north, and then B to C. So for this one, I'm just going to make a little list off to the side. So from A to B, it's north 84 degrees east. From A to C, whoops, I skipped A to C, is south 52 degrees east. And then B to C is 38 degrees south, west of south. Okay, so those are our 3 bearings. When you have one place or one location that has 2 bearings coming from it, you want to start with that one. So I'm going to start with point A. So I'm going to draw my bearing line. Now I know that my picture is going to be on the right-hand side of this line, and how I know that is because A has 2 locations coming from it, 2 bearings rather coming from it, and both of them are east. So I'm going to say put A here, and both of these bearings are going to be on this side. So that's how you know, you can kind of plan out where it's going to go, or you could always just put the line in the middle of your paper. It's fine too. All right, so I'm going to do, I'm going to go in order of the problem. A to C is 52 degrees east of south. So south is down here, east of south is this way. So it's going to be 52 degrees this way. Get your protractor. 52 degrees this way would be about here. So connect. Remember that you don't need to use a protractor, but it's kind of better if you can get one. Just if you're not using one, just make sure, either way, just make sure you're labeling as you go. So this has to be a 52-degree angle here. And C is going to be somewhere on here. I'm not going to put a point where C is just yet because they gave us the bearing from B to C. And so because we have a bearing from B to C, where the A to C and the B to C intersect, that's where C is going to go. So you'll see. So let me label this A. C is going to be somewhere down here. I'm next going to do A to B. A to B is 84 degrees east of north. So here's north. 84 degrees east is going to be to the right. 84 degrees. So I'll put here. Okay, so I'm going to put my point B. I'm going to label this 84 degrees. Since I just labeled that one 84, we can find this one too by adding 84 and 52 and subtracting from 180, you get 44. So you may as well just like fill in all the angles as you go. Okay, so next I have to do my bearing from B to C. So from B to C, I need my bearing line. B to C is 38 degrees west of south. So let's think about south is down here. West of south is going to be this way. So 38 degrees that way. Let me think about here. And so where these two lines intersect, that's where your C is. So you can erase this part. Okay, so, oops, I almost forgot to label this. This is 38 degrees. Really important that you label them as you go. Okay, so next what we're going to do is notice that we only know one angle in this triangle. And they only gave us one side. They said that the plane was flying 250 miles per hour for 2.4 hours. So 250 times 2.4 hours is 600 miles. And that was from A to B. So we do know that this is 600. This question is asking us to find the distance from A to C. So that's your X. Right now, only knowing an X, a 600, we don't know the X, but only being given the 600 and the 44, we can't quite find X right away. We have to find the rest of these angles. This does look like it could be a right angle, but just to be sure, you have to actually find it using like the angles that you're given. Also, too, if some of you aren't even using a protractor, you definitely can't assume that anything is a right angle. So what we're going to do is we're going to remember that these bearing lines are parallel and we have this transversal here. So this angle here, this 84, is alternate interior to this angle here. So we can say that this whole thing is 84 and then do 84 minus 38 to get the other angle, which is 46 degrees. So then we have 46, we have 44, that adds to 90. So then this one would be 90. So it is a right angle, but you do want to do out the math to make sure. Okay, so I'm going to trace the triangle here that we're focusing on just to make it pop a little bit. Really, you could erase all these little arrows that you draw just to figure out which direction you're going. Okay, so now if we're going to find X, you can use either the 44 or the 46. It doesn't matter. I'm going to use the 46. This is opposite. This is hypotenuse, so it's going to be sine. So you're going to have sine of 46 equals X over 600. Then remember to solve, we're going to multiply both sides by 600. So 600 times sine of 46 is 431.6 miles. So there is number one. Okay, so number two talks about Jonathan and Talia, which is me and Mr. Bartlett. And we're planning a class trip to see the Music Cities, which would be awesome, but unfortunately we can't do that, to spend 3 days in each location. So they give us a bunch of bearings. I like to make a list of it all just to keep it nice and organized. So it says the trip will start in Nashville, and from there, zoom out a little bit. From there, they'll head to Miami. So they're going Nashville to Miami, and the bearing is 36 degrees east of south. Then it says, and that's a distance of 836.36. Okay, so it says the next stop is Houston. So they're going to go from Miami to Houston, and this is the bearing. So Miami to Houston, 78 degrees west of north. They don't give us how far that is. And then finally returning back to Nashville, so Houston to Nashville at a bearing of 46 degrees east of north. Okay, so I'm going to do Nashville first. So you want your bearing line. And I'm doing Nashville first because when you don't have like two bearings from the same place, you can just go in order, the order that it's listed. So since they travel from Nashville to Miami, from Miami to Houston, Houston to Nashville, you can do Nashville first. So there's my north and my south. Nashville's going to be here. So from Nashville to Miami, it's 36 degrees east of south. So east of south is to the right of south, so it's going to be this way. Remember, as you go, label it. So this was 36 degrees. And just pick a spot somewhere on there for Miami. Okay, so now we're going to go Miami to Houston. So we need another bearing line. Miami to Houston is 78 degrees west of north. So north is up here. 78 degrees is going to be this way. Okay, so I'll go here for Houston. Now we're going to go Houston to Nashville. So here's where we do have to make it connect back to Nashville. So watch what's going to happen. So if I use my protractor, Houston to Nashville is 46 degrees east of north. So 46 degrees east of north is here. Now, if I connect where I put Houston to that dot, notice it's not going to make a triangle. So what you can do is you can, I just put that Houston like randomly there. Like I didn't know where to put it. So what you can do is I like to line it up like this and then move it down and connect it. Really, you could just connect it and call it 46 degrees, but I like to actually make it accurate. So I'm going to slide this over so that way it connects to Nashville. Okay. So this is 46 degrees. Oops, I just noticed I forgot to label this one. This one was 78 rather. Okay, so this is just drawing it. That's, I'm assuming, going to be the hardest part for you guys, but just take it one bearing at a time and just keep building and going in order of the problem. So now that we have this, let's fill in some more angles. I'm going to zoom in a little bit here. Oh, also from Nashville to Miami, we can label was 836.36. Okay. So hopefully you guys notice that this 36 degree angle is alternate interior to this one, making this one also 36. So if that one's 36 and that whole thing is 78, we can do 78 minus 36 to get that this one's 42. Okay, what else do we have here? This whole thing is alternate interior to this one. So if this is 78 and this is 78, notice now I can get this one. So 78 plus 46, subtract from 180, and you get 56. So this is 56. So your goal is to just like find all the angles, basically. Find as many as you can. How about over here? We have 56, we have 42. So now we can find this big angle, which is really the one we need because remember, we're focusing on the big triangle. Okay, so 56 and 42 is 98. From 180 would be 82. So we don't really need this 36 degree angle anymore. I'm just going to label that this whole thing is 82. Okay, so we have all three angles. We have 42, 82, and 56. we have one side. We're asked to find all the missing interior angles, which we just did, and then the side lengths. So we're going to have an X here and a Y here. Okay, so now to solve this, we can use, this is not a right triangle, so you can't use SOHCAHTOA at all, but we can use law of sines or law of cosines. So when you have all three angles in one side, that would be law of sines. So we can do these two together and then these two together. So we're going to have sine of 56 over 836.36 equals sine of 82 over y. Cross multiply, so you're going to have sine of 56 times y equals 836.36 times sine of 82, divide by sine of 56. Okay, so then you can put all that in your calculator. So you're going to have 836.36 times sine of 82 equals, and then do divided by sine of 56. So that's going to be 999.01, and that's miles. So that's this one here. Okay, and that represents Miami to Houston. Okay, now we just have to find x. So again, we're going to do law of cosines. At this point, you could do, not law of cosines. I was going to say you could do law of cosines, but you'd really want to do law of sines. This is a little bit easier, right? We know all three angles, so why kill ourselves? Let's just do law of sines. So we're going to use the 42 and the x, and then it doesn't really matter, 82 and the 999 or 56 in this one, doesn't make a difference. So sine of 42 over x equals sine of 56 over 836.36. Cross multiply. Okay, so you end up with 836.36 times sine of 42 equals, and then you want to do divided by sine of 56. And it's 675.04. And that's miles. And that's from Houston to Nashville. Okay, so that's our second example. Hopefully you'll be able to try the practice problems on your own. Please email me if you have questions, or you can join our Zoom session at 1 p.m.